Hello, my name is Jakov Kuchan. I'm in charge of product strategy for Mathcad here at PTC. What I'm about to demonstrate is the new functionality in Mathcad 15 for design of experiments. This is the new functionality in Mathcad 15 to support design of experiments. Design of experiments is a well-known methodology, and what I'm going to show you how Mathcad 15, the new functionality in Mathcad 15, supports that methodology. Of course, there are parts of design of experiments that have to happen outside the computational tool such as Mathcad. But for the other elements such as designing the design matrices, regression analysis, factor screening, as well as visualization, Mathcad provides a set of functions to make the job easier. So just a quick overview of the areas. There are four major areas that Mathcad 15 covers: design matrices, factor screening and plots, regression analysis, Monte Carlo simulation. So in each of these areas, there is a ton of functionality over about 30 different functions that all fit together, as well as fit nicely together with the rest of Mathcad functionality to support design of experiments methodology. So just a quick overview: support for factorial design matrices, Box-Wilson, Box-Benken, Taguchi designs, functions for screening the factors as well as modifying design matrices. For factor screening and plots, again, there is a number of functions to support that. A quick screen that gives you a quick overview of how certain factors affect the process outcome. ANOVA, analysis of variance, and plots to visual your results, such as box plots and effects plots and Pareto plots. For regression analysis, we support a number of functions for multivariate polynomial regression. And finally, to simulate results based on your analysis, Monte Carlo simulation functionality. The first part of the functionality is creating a design matrix, and in this example we are looking at the full factorial matrix with 4 different factors. We can create one with 3 different factors. For more than that, you probably need a different design, but this is good enough for our demonstration. And you can see quickly that this metric is represented, is easy to read, and as you will see further on, it fits into the functions that you will be using further on. So we have a run and we have a block. All of these experiments runs are to be done within a single block. And the -1 and 1 represent the low and high factor values. Now, if you wanted to break these down into 2 blocks, there is a block function that does exactly that. And this will break our design matrix by block. Now, the other thing you may want to do, you may want to randomize your design matrix. And for that, you use a randomize function. And notice that it reordered the runs in a random order, and it did that separately for each block. Now, once you created your design matrix, typically you would actually conduct the experiment, and you can enter the data into a matrix. Of course, if you're familiar with Mathcad, you know that there are many ways to import data into Mathcad calculation. In this particular example, we just typed in the data into a matrix. Once you have the experiment data, you can further use it to screen the factors. A convenient function to do that is a quick screen function. In this example, we are looking at the factors and their second-order interactions, and we quickly see that the low average, high average, and the effect is being calculated right there. Now, if we want to consider just the first-order interactions or individual factors, we can do that. If we are interested in screening particular factors, we can just type in those that we are interested in, and this function will quickly calculate and show us the effects of those factors. Now, also there's some graphical tools here, and I'll show you just one example, which is a Pareto plot that shows you how these factors are reflected. So again, to help you make a judgment on how your experimental data looks like.